All right, we are live. So, like I said, we're going to talk today about nth roots and rational exponents. So, roots. There's one type of root that you guys have dealt with before. What is that? Square roots, okay? They are not the only kind of root, though. There are square roots, there are cube roots, there are fourth roots, fifth roots, sixth roots, whatever you want. All of them are in an attempt to solve a certain type of equation, and that certain type of equation looks like this. B to the n equals a, and our attempt is to solving for b. Okay, so if we solve this equation for b, let me go off to the side for just a second, and what if it was b squared equals a? What would you do to solve that for b? You do the square root of both sides, right? That's how we solved those before. So b, and don't forget the plus or minus, right, when we do that, it would be plus or minus the square root of a. Now, the square root technically would be like that. It should have a little 2 in there, but that's like the most basic one that we use. So we don't put a little 2 in there, we just leave it as the root symbol. But technically it's that. So if I had something like b to the third equals a, then b is equal to the cube root of a. We put a little 3 in there, and there's a fourth root, and a fifth root, and a sixth root. Depending on what power you had, depending on what the n was on the first one to begin with, you have all these different kinds of little roots you could use then to solve those equations, okay? So, in general, you've got a couple of different things happening here. So b could be equal to plus or minus the square root, or the nth root, rather, of a then, right? Whatever the power was, that's the type of root that you're using, okay? So we've got this situation where it's a plus or minus, and then it could be just the nth root of a. Now, this kind with the little plus or minus is if n is even, like 2, 4, 6, 8, etc. And this kind is if n is odd. Okay, so question I always get is, well, why the difference? Why do you have to do a plus or minus if the power is even, but you don't have to do a plus or minus if the power is odd? Okay, well, think about some simple examples here, and maybe this will help you to see why. Let's say we've got b to the third equals 8. So is n even or odd on this one? It's odd, right? N is 3. The power is 3. So if I was going to solve this one then, b would be then the cube root of 8. And the cube root of 8, kind of like a square root, you ask yourself, what number, if I multiply it by itself, do I get this as an answer? A cube root, I have to do it 3 times. So what number times itself 3 times gives me 8? And it's 2, right? 2 times 2 times 2 is 8. So the answer to this is 2, okay? Now, if we think about that backwards, think about putting that in the original equation, okay? Do you see why this can't be positive or negative? What if I had said, okay, it has to be plus or minus 2 instead of just 2? Put that back in the original equation. Can I take negative 2 and multiply it by itself 3 times and get positive 8? You'd get negative 8, right? So I can't use both. It's just the one. It's just the positive 2. Because I'm multiplying this number by itself an odd number of times. A positive times a positive times a positive is a positive. A negative times a negative times a negative is a negative. There's no way I could get a positive out of that. So I can't use both. However, if the thing happened to be an even, like let's say b squared equals 16, then that would be b equals plus or minus the square root of 16, which is plus or minus 4. Now think about that for a second. If I do 4 times 4, I'm only doing it twice because it's a square, right? 4 times 4 is 16. But if I use the negative, negative 4 times negative 4, also 16. So because of the fact that it's an even, I can get 16 two different ways. Okay, because a positive times a positive is a positive, but also a negative times a negative is a positive. So both ways work. And that only happens on the even powers. If it was a 2 or a 4 or a 6 or something like that, as soon as you're multiplying something an even number of times, it doesn't matter if it's positive or negative, you can get the same thing. But if you're multiplying a number an odd number of times, like 3 times or 5 times or 7 times, then the sign is going to switch back. So that's why every time you have an even power, you need to make sure you keep the plus or minus. But if it's an odd power, you don't need to worry about it. So actually with this stuff, you're hoping for an odd power because they're easier. You don't have to worry about the plus or minus anymore. But just be careful. Okay? So that's the kind of thing that we're doing here, at least to get started with these roots, is to make sure that we know when we need to have something, whether it's a plus or minus or not, with the type of root that we're doing. So let's try another one here. Let's say we've got b to the 4th equals negative 64. Okay, so how would you handle that one then? What do I need to do to solve it? So first of all, is it an even or odd power? It's even, so I got to make sure I do the plus or minus. It's plus or minus what, though? It will be, yeah. So, well, what's my setup, though? Just let Destiny talk for a second. So it'd be we call that the 4th root. It's the 4th root of negative 64. Okay. So we talked before about how square roots of negative numbers gave you imaginaries. And 4th roots, 6th roots, all of that also give you imaginary numbers. Now, here's the nice thing with this chapter. We're assuming, because things can get a little crazy down the road if we kept using imaginary numbers with this, we're going to assume that just we want real number answers, okay? So we're kind of removing ourselves from the imaginary number world here for a little bit, okay? So for this particular problem then, we would say it has no solution. Just leave it at that, okay? Because this gets crazy enough without that, so let's just, we're going to avoid having to deal with that. So there'd be no real answer. So you can use this symbol if you want for no solution. The circle with the slash through it. Okay. Now, that being said, you can't just assume because this is a negative number it's not going to work. Okay. So if I give you another one here real quick, what if we had like b to the 3rd equals negative 27, let's say. So then we'd end up with b equals, now it's an odd power, right? So we don't need the plus or minus. So it'd just be the cube root of negative 27. So some of you guys might look at that and say, oh, it's a root of a negative, that would be imaginary, so no solution on this one too, right? But this one, but if it's an odd power, you can do it, right? What negative number, if you multiply itself 3 times, gives you negative 27? It's negative 3, right? So this one actually has a solution to it. It's negative 3. So the odd roots, you will always have an answer. It's only the even ones that are the problem, right? If you take an even root of a negative number, no solution. That you can go to the bank on. That one is definitely that way. But if it's an odd root of a negative number, you can take a negative times a negative times a negative, and get negative as an answer, right? So you're able to do it, so you don't worry about those. Okay. Okay. So this is using the nth root stuff. So our first bullet up there on the board was finding nth roots. Okay, and this is how we do that. Now your textbook, just so you are aware, writes them a little bit differently. Okay, but you're basically doing the same thing. Okay, so their setup, they'd say something like, find the nth root for the following situation, and they'd say something like n equals 3 and a equals 125. So you basically just take this information and you're going to plug it into this little equation that we started with. Okay? So they give you an n and an a and they want you to find b. Okay? So in this situation then we'd have to go, I think Destiny you were saying it. You can say it again. Mm-hmm. Right. And so then it's just like all the other ones we were doing. Okay? So b to the third equals 125. And I think this might be like question 5 in your homework or something. I'm not sure. I had that written in my other one. So anyway, let's just solve this real quick. What number to the third power equals 125? Anybody know? 5. Good. So we could say b equals the cube root of 125, which we know is equal to 5, because 5 times 5 is 25, and then 25 times 5 is 125, so it works. So b is exactly 5 on that one. Okay. All right, so the next part, we're going to talk about these rational exponents. So a rational exponent, well, let's start with, what's a rational number? You guys remember what rational means? That is an example of one, but what does it mean? You're close. It's any number that can be expressed as a fraction. The word rational means fraction. Okay? So we're going to be looking at rational exponents. So exponents that are fractions instead of whole numbers. Okay? Now it's not as bad as you might think. I want to just do a little bit of work here with some stuff to show you why these are what they are. Okay? So you might look at these and think, I think this might be too simple, but it's supposed to be simple. So all I want you to do here is simplify these. So I've got the square root of 2 squared, the cube root of 7 to the third, and the 111th root of 9 to the 111th power. Don't overthink it. Just write down solutions to each one of those. The first one we've done before, and the other two kind of follow the same pattern. So what's the square root of 2 squared? It's just 2, right? The square and the square root cancel each other out. So following that same logic, what's the cube root of 7 cubed? 7. And what's the 111th root of 9 to the 111th power? 9. Right? There's no trick to that. That's it. Whatever, if the root and the power are the same, they cancel each other out, no matter what kind of root it is. Okay? What? Then you got to do something else that we'll learn about later. But I'm just trying to show you a little connection here. So I got another set of 3 problems for you. Now these ones are going to look weird. However, they are no more difficult than the other ones you just did. Okay? It is. Now, the reason why, you guys remember this thing that's called a power of a power? No? Okay. Well then, actually, let me do it on here. So power of a power property, so what's going to help us get through these if you have a power, x to the a, with a power on top of that, to the b, you can just take these exponents and multiply them. Okay, so do you see how I have a bunch of power of powers in there then? Okay, so what's 2 to the 1/2 squared? 2. Because it's 2 to the 1, right? Because 1/2 times 2 is 1. So this is 2 to the 1, which is 2. All right, next one. 7 to the 1/3 to the 3rd, 7, right? Because 1/3 times 3 is 1, so 7 to the 1 is 7. And last one's 9, right? Same idea. Okay, so the reason I had you do these is I want you to take a look at this set of 3 and that set of 3 and see if you can recognize a new way we can write a square root or a cube root or a whatever root. Okay? What's the only difference between this set and that set? Yeah, there's no root symbol. Instead of the root symbol, what do I have now on these things? I have fractional exponents or rational exponents, right? So instead of writing a square root, how can I rewrite that now? You can do a 1/2 power. Instead of a cube root, a 1/3 power. Instead of a 1/11 root, 1 over 1/11. What? I said instead of a 1/11th root, you can make it 1 over 1/11. So see how we're doing this little conversion here? So there's this connection of any kind of nth, I'm using it in general now, so any nth root of a can be rewritten as a to the 1 over n. Right? That's what we were doing in those. It's just showing you that you're getting the same answer if you do that. So this is kind of a little conversion. It's a way to rewrite a root as a fractional exponent instead. So if you see things that have exponents that are fractions, you can turn them into roots. That's what that means. That's what they are. They're roots. And if you have things that are roots, you can turn them into fractional exponents because sometimes that helps us to work with them so it's easier to do than to try and sit there with the root and mess with it. Okay? So we're going to use this. We're going to do a little bit of calculating here, doing some roots by hand, and then I'll show you how you can do these things on the calculator too. So if you see something like 16 to the 1/4 power, what is that actually? Somebody raise your hand and tell me. Yeah, Sam. The answer is 2, but if I'm asking you to take 16 and raise it to the 1/4 power, what am I actually really asking you to do? We say 4th root. So it's the 4th root of 16. We don't need a plus or minus this time. We only need a plus or minus if we are dealing with solving an equation by using a root. Notice all those ones that we started with, those nth root problems we were doing at the beginning, I was solving an equation for b, and that's when we had to concern ourselves with the plus or minus or not. This one is set up in such a way, 16 to the 1/4 power is just the positive, because I wrote it that way. It's just it's positive 16 to the 1/4 power. That's it. So there was no little plus or minus sitting in the front of this already. Okay? So I'm only dealing with the positive root. Okay? So that's an important distinction, because if you're solving an equation, you have to worry about is it even or odd, and then do I have to have the plus or minus or not. But if you're just presented with a, hey, do this, you're not actually solving an equation, you just need to simplify this expression that I have on here, and you don't need to worry about that. So 4th root of 16. So what number multiplied by itself 4 times gives you 16? And the answer is 2. Yeah. Okay. Let's try another one. Okay, so 27 to the 1/3 would be what then? How do we say it? It's a cube root, or a third root if you'd like to say it that way. That's fine too. But cube root or third root of 27. And that is 3, right? Because 3 times 3 times 3 is 27. Okay. So what about that? Now I'm throwing you for a loop. So if it's 2/3, it's not just 1/3 or 1/4 or whatever. Now I put a 2 on the top instead. You can do it. You got to think about that power of a power property. And there's one little step in the middle that I think if I show you this, then it should make sense. Yeah, good job. So it's going to be 8 to the 1/3 power squared. So take a second. Does that make sense? Power of a power, you multiply, right? 2/3 you can break down into 1/3 times 2. Okay? And we know what a 1/3 power does. It's a cube root. And then we just have to take that answer, cube root of 8, whatever that is, and square it. Okay? So, this is the cube root of 8. What is the cube root of 8? 2, right? 2 times 2 times 2 is 8. So it'd be 2 squared, which is 4. Yeah, good. Okay, let me give you one more like that. See if you guys can do it this time. So how about 125 to the 4/3 power? So take a look at how we just did the last one. See if you can break it up the same way. Which is? Yep.
Wait, so I'm confused. Like, alright, when it goes to the, when you put it into 1/25 to the 1/3 times 4, then you cube.
You do the inside first. So the cube root of 125, which is what? 5. So we've got 5 in the parentheses to the 4th power. Right? So 5 to the 4th power, you can probably do this in your head still. Let's try it. You got to multiply 5 4 times. Okay? 5 times 5? It's 25. 25 times 5? 125. 125 times 5? 625. Okay. So,
How do you remember that?
well, it's not a matter of remembering it. I just multiplied it in my head. So what I did was I took 125. I broke it into 125. 100 times 5 is 500. 25 times 5 is 125, and I added them together. So 625. But for some people, that's kind of challenging to try and do in your head, though. But, yeah, that's what I was doing. So, all right. So what we just found here, then, was kind of a new relationship here. So if we have a to the m over n, think about what we were doing. Like, just follow this last example, and we're going to write out kind of a generic formula for this. We took the number, this 125 was our a in this last one, right? So it's going to be a to the 1 over n to the m, right, is what we did? You follow that? Okay. And so this right here, though, was an nth root of a, right? So really what we got here is a to the m over n is equal to the nth root of a, because that's ultimately what we ended up doing in the middle, right, was taking a root of it and then raised it to that last power, whatever it was. So if you have a fraction, m over n, where it's not just 1 over n, but there's a number up here, you just do the root to that power, whatever that m is. Okay? So this is a really important connection that we're going to be continuing to use in the future, too. If you have some kind of a rational exponent, whatever it is, it can be anything over anything, we can turn it into this. Create a root and raise that to a power. Okay? Okay, so that's fractional exponents. Now I said you guys can do some of this stuff on your calculators as well. So I'm going to give you some ones that you wouldn't be able to do by hand because the roots don't work out nice. Okay? So what if we had something like 6 to the 3/4? So how would I handle that? Okay? Well, you can type it in just like that. Looks just like that. You just got to use the little caret on your calculator. So for 6 to the 3/4, I'm just going to type a 6. You guys all know where the caret is, right? Right above the division, right below the clear button. That's your little caret. That's how you raise things to powers that are not just squared. Because it looks like a carrot. I don't know. Anyway, so we were doing 6 raised to the 3/4. So in parentheses, be careful. You need to put it in parentheses. 3 divided by 4. Right. So like I said, doesn't work out to a nice, neat number this time, right? So this would be a calculator one. You can't do that by hand. All right. Ultimately, what you would be doing there is the 4th root of 6 raised to the 3rd power. But the 4th root of 6 is not a nice integer. Okay. It's this like crazy decimal. So we can't do that by hand, so we got to allow the calculator to do that for us. So this is rounded off. Let's take it 3 decimal places. 3.834, I guess then, right? Okay. Okay, and then what if you had the 5th root of 98? Okay, so for something like this one, your calculator actually lets you do it a couple different ways. If you want to turn that into a fractional exponent and do it that way, what would be the fractional exponent for this one? Be 98 to the 1/5. So I'll show you that one first because we just did that same kind of thing. So 98 to the 1/5. All right, you can do it that way, and the answer is about 2.5. Now, if you want to actually do it as a root, if you want to, because remember, there's a square root button on your calculator, right? And in fact, there's a cube root button on your calculator, if you've ever found that before. And there's an X root button on your calculator, too. So you can do any kind of root you want on the calculator. The only thing is, if you're doing a root that's a higher n than 3, you have to give it the number first. So this one was a 5th root, right? So I'm going to put a 5 there first. Then if you go into math, and you come down here, see there's the cube root. Here's the x root. So I have my 5 in front already. I'm going to grab the x root. Now it's a 5th root. I have a 5, then the x root. Now it's a 5th root ready to go. I want the 5th root of 98. So 5th root of 98, same thing. Okay? So whichever way you want to do it, whichever you prefer, doesn't matter to me. But that's how you can make it look either way and get the same answer. So in any event, again, if I were to round this thing off to like 3 decimal places, it would be 2.502, I guess. Okay? So that's using your calculator to do some of those roots. Okay, so that's fractional exponents. Need to show you one last little thing that you might see with your exponents. So we've talked about, to kind of summarize here now, we've talked about exponents in the past that were integers. We've talked about exponents that are fractions now. We can also have exponents that are negative numbers. Okay? So I want to show you a little pattern here and see if you can catch what's going on. So we're going to do 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st, 2 to the 0, 2 to the negative 1, 2 to the negative 2. So these top 4, pretty sure you guys can do. Don't use a calculator. Just do it in your head. You can do that. And there's going to be a pattern with these numbers as we go down this list. And I want to see if you can fill in the rest of it using the pattern that you see. Okay? So try that once. Don't use a calculator. 2 to the 4th, 2 to the 3rd, 2 squared, 2 to the 1st. Write those all down. Don't let it out of the bag just yet. And then finish the pattern. Okay, finish the pattern. So I'll give you a couple minutes to do that. Okay, so here's what we should have. Right, the pattern is you're dividing by 2 as you go down, right? 16, 8, 4, 2, and so 2 to the 0 should be 1, because 2 divided by 2 is 1. And then if we continue that pattern, so I let my exponents become negative now, if I continue that pattern, I should then have 1/2 and then 1/4, right? Keep dividing by 2. Okay, so just to drive it home here a little stronger, let's do the same thing with 3 for just a second. See if you guys can tell me any patterns that you see after we've done this with a different base as well. I think this should clarify it. So 3 to the 4th, that's 3 times 3 times 3 times 3. I'll just let you know, that's 81. Okay? So the last set we were dividing by 2 each time. What do you suppose we're going to do this time? Divide by 3. So 81 divided by 3, maybe you can't do that in your head. That's 27. So 3 to the 3rd is 27. 3 squared is 9. 3 to the 1st is 3. So we're dividing by 3 each time. So what's 3 to the 0? 1. 1/3. 1/9. Yeah. Okay. So I'm going to come off to the side over here. Anything to the 0 power is 1. No matter what. Do you guys see that? No matter what base that would have given you, 2, 3, could have been like 10 or whatever, by the time you get to the 0 power, it's going to be 1 in every pattern you do. So this is always the case. And this is a very nice little property of exponents that we can use. Anything to the 0 power is 1. Doesn't matter. Okay. Now, here is the other one we're concerned with. And this one's maybe a little trickier to come up with, but see if you can see the pattern in there. Does anybody think that they can tell us what could be a little formula we could write for a to the negative n? It's going to be a fraction. Mm-hmm.
It's going to be 1 over n.
You're close. It's always 1 over whatever the power was if it were positive, right?
1 over n times something. I think I'm overthinking this.
Well, it's a to the negative n equals 1 over a to the n. So, like, 3 to the negative 2 is the same thing as 3 squared, except it's a fraction of it, right? This 9 is a to the n. This is 1 over that. 1 over a to the n. Just like 3 to the negative 1 is the same thing as 3 to the 1, but flipped into a fraction, right? So this is a to the n. So this is 1 over a to the n. Okay? So you take whatever you would have gotten with the positive exponent and flip it into a fraction then. Okay? So this is the relationship that we have if we have a negative exponent. It's 1 over whatever that is. Okay? So I'm going to do just a couple of examples using some negative exponents here real quick. Okay? Then we'll move on and we'll be done. Just want to solve some quick equations at the end here and then we'll be done. Okay. So let's say we have 3 to the negative third. And I want to do this by hand, figure out what this is. 3 to the negative third power. Okay. So we know 3 to the third is 27, right? So 3 to the negative third, nope.
Negative 1. Oh, 1 over 27.
Just 1 over 27. It's whatever you got doing this, flip it into a fraction. Be careful. The most common mistake with this is to have a negative in your answer. They're never negative. If you have a negative exponent, it doesn't make the answer negative. It's still a positive, it's just a fraction. Okay? So what about, like, see if you can do this one in your head. What's 4 to the negative 2 then? 1 over 16. You guys get it? See what we're doing? Or if I had, like, 8 to the negative 1, what would that be? 1 over 8, because 8 to the 1 is 8. So we keep getting these little fractions each time. Okay, last one of these. See if you guys can do this. This will be my little challenge one for you here. Yeah. So I'm going to leave it as, I'm going to leave the base as an x and just see if you guys can simplify this. I want you to turn this into a root. So x to the negative 2/3. Okay? So, first things first, the negative means that it's going to flip into the denominator. Okay? Think about, we just talked about over here with this relationship. Okay? If it's to the negative, it's 1 over that without the negative in the exponent anymore. So see if this first step makes sense to you then. So if it's x to the negative 2/3, that's the same thing as 1 over x to the positive 2/3. Right? Flips it into a fraction. We lose the negative on the exponent if we take that thing and put it in the denominator then. That's what we were doing on the other side. Okay, and then to a 2/3 power, this over 3, that means it's a cube root, right? And then we got it squared. So this becomes 1 over the cube root of x squared. Okay? So if it's a fraction and it's negative, you've got a root in a denominator. That's what that means. You've got a root in a denominator. Both of those two ideas happening at the same time. Negative puts it in the denominator. A fraction makes it a root. Okay? So it's just following both of those two rules that we talked about and putting them together there. This, I'm not going to do a lot with you guys with that. I know that's hard because there's a lot of stuff at the same time. But that's the idea, though. It can be done. We need to do some solution work first, and then we'll be all set. So I'm just going to do one of these with you guys. And we're going to go ahead and use a calculator to do this. Now, when you guys were in Algebra 1, you probably solved equations very similar to this, except for it wasn't x to the 6th, it was just x. Right? If it was just 4x minus 8 equals 120, we can totally do that. That's easy, right? Pretend that's what it is here for a second. Tell me what you would do to get this one started. Add 8, okay. So if I add 8 to each side, now I've got 4x to the 6th equals 128. Okay, and then what would you do? Divide each side by 4, okay. And 128 divided by 4 is 32. Okay. And so if it was just x, there's your answer, right? It would be x equals 32. Okay, so this is just like the ones we had at the very beginning, right? We have this equation. We're trying to solve for x, but x is raised to a power, so I have to do an nth root to solve it. So what kind of root am I going to need for this one? A 6th root, okay. So x equals, now is it plus or minus or just the root? It's an even root, right? So plus or minus, because I'm solving an equation to do it, plus or minus the 6th root of 32. Now the 6th root of 32 does not work out evenly, so feel free to use your calculator on that one. If you want to use the x root, that's fine. If you want to make it into a fraction and do it that way as a power, You can do it that way too. Either way, it is about 1.782.
Oh crap! I did it wrong.
Because I did 32 to the 1/6 power on my calculator.
I accidentally did it to the 120. I accidentally did 1 to the square root of 128. I don't know why.
Oh, okay. All right, so our answers, there are two of them, plus or minus 1.782. Okay, so I just wanted to show you one of those just so you had a little exposure to it, but it's pretty much what we were doing at the beginning. It's just you solve an equation. That's part of the process of solving the equation. So, all right, so your homework on this stuff, it's page 241 to 243. I have it written down already. So 5 through 31 odd, 35 to 43 odd, and then number 46. And that's the whole thing. All right. Like I said, it's about the same length as far as number of problems that you've seen in the past, except a lot of these go very quickly because you're just simplifying or solving roots that you can do like in 1 step or 2 steps real fast. So, all right. So you guys got about 20 minutes, 25?